Good day everyone! Welcome to another video lesson discussion in statistics and probability. This time we'll have finding possible values of a random variable. And these are the objectives of our discussion. Find the possible values of a random variable, construct the probability mass function of a discrete random variable and its corresponding histogram, and then compute probabilities corresponding to a given random variable. There are three steps in finding the possible values of a random variable. The first step is to list the sample space. Okay, so we have discussed the sample space in our previous lesson. The second one is to count the number of random variables in each outcome and assign the number to this outcome. And the last one is to make a conclusion. Let's have an example. A coin is tossed thrice. Determine the number of heads that result from this experiment and determine the possible values of the random variable h. Okay, in our given example, our random variable is a capital letter H that represents the number of heads. Okay, so that is our discrete random variable, the number of heads wherein it is represented by the capital letter H. Now, in tossing a coin, using the Philippine peso, we know that we have the head and the tail. And then if we're going to toss a single coin on the first toss, okay, so to determine the possible number of random variable, we'll be using the tree diagram. Okay, on the first toss, the possible outcome could be a head or a tail. Okay, so on the second toss, if we have a head on the first toss, the possible outcome is either again a head or a tail. Now, if we have a tail on the first toss, on the second toss, we could either have a head again or a tail. Okay? Now, on the third toss, so it could be a head or a tail again for all those possible outcomes. Okay? So we'll just simply put the possible outcomes here, which is your head or your tail. Now, to get the outcome, we will just list them down. Okay? So, on the first toss, you have a head or a head again on the second toss or a head again on the third toss. So, that will be your first outcome. Now, on the other hand, if we have a head on the first toss, a head on the second toss, we can either have a tail on the third toss. So, that will be the possible outcome. Now, if we have a head on the first toss, but a tail on the second toss, we can either have a head or a tail on the second toss. So, we can have head, or head, tail. Can you follow? Okay. Now, if we have a tail on the first toss, a head on the second toss, we can have a head on the third toss, or a tail. So, we have here now tail, head, or tail, tail. Now, but if we have a tail on the first toss and a tail on the second toss, we can either have a head or a tail on the third toss. So, we will have an outcome which is tail, head, or three tails. So, these are the possible outcomes, or these are our set of all outcomes, or our sample space in our experiment tossing a coin 3 times. Did you follow? How are you going to list down the procedure, or how did you follow the procedure in listing down the possible outcomes when you toss a coin thrice? Okay. Okay, we are done with step number 1 in finding the values of random variable. So for step number 2, the first thing that we're going to do is to list the outcomes in a table. So we have here a table in 2 columns. So for the first column, we were going to list down all the outcomes that we have listed in the first step. So these are the outcomes. And on the second column, we have here the value of random variable h, which represents the number of heads. So for step number 2, you're going to count the number of the random variable. Our random variable again is the number of heads. So count it in each outcome, and then we're going to assign number in the outcome. So here on the first outcome, we have here 3 heads, so we'll just write 3. On the second outcome, you have 2 heads rather. Same with outcome number 3. On the next one, we have 1 head, and then we have 2, and then 1, and then we have 1. And on the last outcome, there is no head, so we have to write it 0. So this is the step number 2. Now, step number 3 is to simply write the conclusion. So therefore, in tossing a coin 3 times, these are the possible values. What are the possible values? So we can either have 3 heads or 2 heads only, 1 head, or no heads. So these are the possible values. So the possible values of the random variable are 0, 1, 2, or 3. So that will be your step number 3, making the conclusion. Did you follow on how to find the possible values of random variable? Okay, so take. Okay, let's have another example. 2 balls are drawn in succession without replacement from a bowl containing 5 red balls and 6 blue balls. Let x be the random variable representing the number of red balls. Find the possible values of the random variable x. Okay, so in our second example, it is our random variable is represented by the capital letter X, and it represents the number of red balls. So we're going to get 2 balls from the bowl without replacement, meaning when you draw the first ball, you don't have to put it back in the bowl. Okay. So again, using tree diagram, so if this is on the first draw, since there are only 2 colors, so we could either get a red or a blue balls. Again, just follow the tree diagram. And then on the second draw, okay, so you can either have again a red or a blue, a red or a blue. So, and then we're just simply going to list down the result. So, if you have a red on the first draw, you can either have a red on the second draw or a blue. So that will be red, red, or red, blue. But if we have a blue on the first draw, your second draw could either be red or blue. So we can have blue, red, or blue, blue. So did you follow? Okay. So these are again your set of all outcomes or your sample space. So we only have 4. Okay. So I hope that is clear. That is for step number 1. Okay, so we're done with step number 1. So for step number 2, we'll just have a 2-column table. So on the first column, we have here the outcomes. So we'll just list down all the outcomes that we have obtained in step number 1. So you have here red, 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 blue, blue, red, and blue, blue. Now for the second column, we will do step number 2. So we'll just count the number of random variable or the number of red balls. So on the first outcome, we have 2 red balls. So we'll just simply write 2, 1, 1, and 0. And then after that, we just simply make a conclusion that the possible values of the random variable when we draw 2 balls in a bowl could either be no heads or no 0 red balls, 1 or 2 red balls. Did you follow? Okay. Okay, now that you know how to find the possible values of random variable, we can now construct a discrete probability distribution. There are actually 5 steps in constructing a discrete probability distribution. So we have construct the frequency distribution of the values of the random variable. Actually, this one covers the first 3 steps that we did in the previous example. What are those first 3 steps? So we list down the sample, we count the number of the random variables, and we make a conclusion. So this step summarizes the first 3 steps. Okay? Now, we will only continue the table that we had or that we have in our previous examples for step number 4 and step number 5. So, for step number 4, we will assign probability values or P of X to each value of the random variable. So, we just have the probability. And the last step is we're going to construct a probability histogram to describe the probabilities. Before we proceed to steps number 4 and 5, let us have first histogram. Okay, so a histogram is just like a bar graph. Okay, the discrete probability distribution can be graphed to form a probability histogram. So on the x-axis or the horizontal axis, we're going to place the value of the discrete random variable X or any letter that you have assigned, and it should be placed on the center of each bar. While on the y-axis, you're going to place the probabilities that will serve as the height of each bar. So, we will have it on step number 5. Okay, let's have now the fourth and the fifth step for problem number 1. So, first step is we list down all the samples. Okay, our problem here is tossing a coin thrice, and these are the possible outcomes. Our random variable h is the number of heads. Okay, so these are the possible numbers. Okay, and step number 3 is we make a conclusion. Now, for step number 4, that is actually making a probability distribution. So we will have an additional column of 3. So we have here, now, PBRB corresponds to your possible values of the random variable, which is actually step number 3, your conclusion. So if you still remember the possible values here, looking at this, the possible values of the random variables or the number of heads could be 0, 1, 2, or 3. So we just write down the conclusion in a table. Okay. Now, for the frequency refers to the number of times 0 appear here or how many times 1 appear here. So, looking at this, 0 or there is no head if there are 3, if you toss a coin thrice and it appears na 3 tails ang outcome. So, the frequency of 0 is just 1. Now, for number 1, or there is only one head, you can count it here. So, the frequency or the number of times it appears is 3. Just like for number 2, it is also 3. And for number 1, that is, for number 3, or 3 heads, that is only 1. So, a total number of 8, since you have 8 sample space, or say 8 outcomes here. Okay. So, this is for column number 4, the frequency, or the number of times it occurs, or the number of occurrences. Now, for the probability, okay, the probability is what is the chance of appearing no head. That is how you do, that is the meaning of that. Or what is the chances that there is only one head? Or what is the chance of having 3 heads? Now, you will just get the probability here in the frequency. Since we have here a total of 8, so the chance of getting no heads or 0 is 1 over 8. And the chance of having one head is 3 over 8. Okay, having 2 heads or two possible values is 2. So you will also have 3 eighths and you have 1 over 8 for 3 heads. Okay? So if we're going to add up this one, 1 8 plus 3 8 plus 3 8 plus 1 8, that will only give you 8 over 8 or 1, which is actually the property of a discrete probability distribution. Property number 2 is that states that the sum of all probabilities should be 1. Okay? So is that clear? Did you follow how to make the probability distribution? Okay, so this is just your conclusion, and then you look at this table, the number of occurrences or frequency, and then the probability is simply here over the total. Okay, the number of the frequency over the total. So that is your probability. Okay, so for number 5, we're now going to construct a histogram. Okay, as I've said earlier, it is just like a bar graph. So on the horizontal axis or x-axis, you will place the possible values of random variable, which is the number of heads, and we only have 0, 1, 2, or 3. So we'll just place it at the center. And then on the vertical axis or y-axis, we're going to have the probability. Since we have a total of 8, so we'll place 8 here. And then we just simply shade the probability. So 1 over 8, that will serve as the height. So we'll just, for 0, the probability is 1 over 8. So we'll just shade it here. And then for 1, the probability is 3 over 8. So you will just shade 3 squares out of 8. And again, for probability of getting 2 heads, that will be 3 over 8 also. So you just shade again 3 squares out of 8. And for 3 heads, that is 1 over 8. So this will be your shade. And this is now your histogram. Is that clear? Okay, just remember the labels for the y-axis, that is the probability, and for the x-axis, that will be your random variable, whatever is asked in the problem. Is that clear? Okay, so this is how you construct a discrete probability distribution. That is just the continuation of your steps in finding the values of random variable. Okay, so I hope everything is clear. Okay, so this time let's have the problem number 2, wherein you are drawing a 2 balls in succession in a bowl. Okay, so our random variable h is the number of red balls, and these are the outcomes. So again, just like we did in problem number 1, so we will construct a probability distribution, the 3 tables, and this is your conclusion. The possible values of the random variable number of red balls is either 0, 1, or 2. So to get the frequency, look here how many times 0 appear. So you will have 1. For 1 red ball, you have 2. And for 2 reds, you will have also 1. A total of 4. And then for the frequency, the number of occurrences or the number of frequency over the total. So that will be 1 over 4, 2 over 4, or 1 half. But you can have it in that way so that it will be easier for you to add the total number later on. And then for 2 reds, that will be 1 over 4. So when we add again, that is 1/4 plus 2/4 plus 1/4, or that is equal to 4 over 4 or 1. So this is your step number 4. And the last step for the histogram, the same process. Here on the x-axis, we have here the number of red balls. So we have 0, 1, or 2. And for the vertical axis, you have the probability 0, 1, 2, 3, and 4. And then we just shade it. So we will shade 1 square out of 4 for 0 red balls. And then you have 2 over 4 and then 1 over 4 again. So this is now the histogram for problem number 2. Step number 4 and step number 5. Okay, any question? Okay, so I hope that first 2 example is clear. So that is how you construct a discrete probability distribution. Now let's have sample application problem for probability distribution. The following data shows the probabilities for the number of cars sold in a given day at a car dealer store. So here, on the first column, you have the possible numbers of cars being sold in a day. So you have here no cars being sold in a day, or it could be 1, 2, 3, up to 10 cars. And on the second column, that is the chance or the probability that no cars is being sold, you have 0.10. 1 car is being sold, 0.15, and so on and so forth. Now, if we're going to add up all these probabilities, this will be equal to 1, which is the property of discrete probability distribution, property number 2. So, your problem, the first problem is to find the probability that less than or equal to 2 cars is being sold in that particular day. So, since you have here less than or equal to 2, if you have no cars is being sold is 0.10, 1 car is 0.15, and 2 cars is 0.25. has a 0.25 probability. So all you have to do is to add all those three probabilities. So you will have 0.10 plus 0.15 plus 0.25 is equal to 0.50. That will be the probability of selling either exactly 2 cars, only 1 car, or no cars at all. Is that clear? Okay, next we have find the probability of selling greater than 4 cars in a day. So greater than 4, that means they sold, or 5 cars is being sold, or 6 or 7 or 8 or 9 or 10. So that means we just have to add up again from 5 cars up to 10 cars. So that will be this one. And that will give you 0.27 probability. Okay, or 27% if you convert it to percent. Okay, next, find the probability that greater than or equal to 2 but less than 7 is being sold. So greater than or equal to 2, that means it could be 2 cars in a day, 3, 4, 5, or 6, because you have here less than 7. Okay, so you just add up again the probabilities of selling 2 cars, 3 cars, 4 cars, 5 cars, up to 6 cars. And that will give you 0.62. Can you follow? Okay, then last example, find the probabilities of selling greater than or equal to 8 but less than or equal to 10 cars in that particular day. So, greater than or equal to 8 up to 10. So, add these 3. 0.04, 0.025, and 0.015, and that will give us 0.08. 0.08 or 8%. Did you follow? Okay, so this is application problem for probability, discrete probability distribution. This ends our discussion for today. For your output, visit the Google Classroom and kindly subscribe, like, comment, and share. Thank you.